When you look at these two equations, they may at first glance look like they're pretty normal equations, but when you read that title, Find Special Solutions, the title should tell you that these equations are perhaps not all they seem to be. So let's go ahead and solve them and see what's so special about them. So the first equation, 5x plus 5 equals 3 times the quantity 5x minus 4 minus 10x, has variables on both sides of the equation. And the left side seems like it's okay. 5x plus 5 doesn't have anything unusual going on. The right side does have our variable trapped inside these parentheses, so let's go ahead and do the distributive property. 3 times 5x is 15x, and then 3 times negative 4 is negative 12, and then we'll tack that minus 10x onto the end, and that's what the problem looks like after we do the distributive property. And after doing that, we now have three different terms that have variables in them. We've got a 5x, a 15x, and a minus 10x. And so one thing that we can do is, since the 15x and the minus 10x are on the same side of the equal sign, we can actually combine these together. We cannot combine terms that they're on opposite sides of the equal sign, so this 5x over here cannot be combined. But the 15x and the minus 10x can. So again, we're going to have to leave our left side alone for now. Leave that as 5x plus 5. But on our right side, the 15x minus 10x can be combined, and 15x minus 10x is 5x. Got that minus 12. Okay, and then whenever we've got variables on both sides of the equation, our goal is to get the variables on the same side. So we need to either subtract 5x from the left side or subtract 5x from the right side. So we've got 5x on both sides. Normally, when we have a problem like this, we ask ourselves, which one do we subtract so that we don't have a negative? But here we're subtracting the same thing from both sides. Minus 5x and minus 5x. And our x's are going to go away. So we end up with 5 on the left side and negative 12 on the right. This was the subtraction property of equality. Did we do something wrong? All we did was the distributive property, and we combined like terms, and then we did the subtraction property. Did we mess up somewhere? And the answer is no, we did not mess up. And this is why the title of this is Finding Special Solutions. This is what is so unusual about this equation. Just because the variables cancel out and we're left with no x's at all does not mean we did something wrong. It means this is a special solution. The thing that we ended up with, 5 equals negative 12, is, to put it quite simply, not true. 5 does not equal negative 12. So what does that mean in the context of this problem? It means there are no solutions. There is no value of x that works in this equation. There are no solutions. In fact, we could have told there were no solutions from this step right here. Let me come write this over here to the side. 5x plus 5 equals 5x minus 12. From this step right here, we could have told there weren't going to be any solutions. Both sides have 5x in them, so we know whatever you plug in for x, the 5x's are going to be the same. But the left side, we take that value and add 5 to it, and the right side, we take that value and subtract 12 from it. So no matter what, the right side is going to go up 5, and the right side is going to go down 12, and the left side is going to go up 5. No matter what value of x we have, those two sides are never going to be equal. So this one has no solutions. Let's take a look at the next one. Similar to the last one, the right side doesn't have anything for us to do. It's just 6b minus 10. But we can do distributive property over here on the left. 3 times 2b is 6b, and already your spidey sense should be tingling because we now have 6b on both sides of the equation. This is minus 7 equals 6b minus 10. So we've got some things we can combine after doing distributive property. Let's combine these. Negative 3 minus 7. That'll give us negative 10. So we got 6b minus 10 equals 6b minus 10 after combining like terms. And you can see that both sides are exactly the same. Both sides are 6b minus 10. If we took this one step further and subtracted the 6b from both sides, we would end up with negative 10 equals negative 10. So this is kind of like what we got last time, where our variables went away, except now we end up with something that is true. Negative 10 does equal negative 10. So this doesn't mean that there are no solutions. This means any value of x will work. No matter what number you pick for x, it will work in this equation. This has infinite solutions. Any number you pick will be a solution. And again, we could have told from this step that there were going to be infinite solutions. 6b minus 10 equals 6b minus 10. You pick a value for b and plug it in for 6b. Those are obviously going to be the same. The left side takes that number and subtracts 10. The right side also takes that number and subtracts 10. So if you take a number and subtract 10, and I take that number and also subtract 10 from it, it doesn't matter which number it is. If we both subtract 10 from the same number, we're going to end up with the same number. And that is why there are infinite solutions. Anything you pick for b is going to give us a correct equation. So these are our two special solutions. If you end up with something that is not true, like 5 equals negative 12, you're meaning your variables cancel out and you're left with an untrue statement, a wrong equation, you have no solutions. If your variables go away or your two sides of the equation are exactly the same, like negative 10 equals negative 10, you have infinite solutions. And those are our special solutions.